Sauce here. This is a video lesson for Python programming, PyLife. PyLife is a project. This is a project video where I'm going to show you an example of a program that accomplishes the objectives of the project and then read the objectives and reflect on how the program accomplished them. I have a version of PyLife that has been running for a little while. This is a simulation where we have two populations of instances. We have a population of cheese and a population of mice, and each is represented by a graphic. The mice run around somewhat at random. They bounce very similar to balls bouncing off the edges of the screen. The mice do not track or head towards the cheese. If a mouse gets close enough to the cheese to interact with it or collide, then the mouse will eat the cheese and be able to survive longer. The cheese populates, there's a few about every second and a half that appear at random places on the screen. Now, this simulation will remain in a living state if the mice can eat enough cheese to keep going, and when they do, they also generate more mice. And the cheese is able to sustain at least one living mouse for as long as possible. If the mice can't get to the cheese, they will eventually die. And if all the mice die out, the simulation is over. It will restart. The numbers that are printed are the number of times that the simulation has run its course. The simulation begins with about 50 mice on the screen and about 50 pieces of cheese, but so many mice eat the cheese very quickly, so there's a population boom in mice. The cheese usually get eaten, and then the simulation might find some stable pattern that will persist and keep mice alive for a while. The lifetime is the number of seconds that the simulation has been in a living state. And when all the mice die out, then the simulation is over, and the time gets recorded from the previous rounds and printed above. So we can see a history of the amount of time that this simulation is able to run in the rounds. The first one lasted for a brief 13 seconds. We have one simulation that went for 161 seconds. So there's quite a difference in how long it takes for the mice to die out. Let's keep this running and look at the objectives. The overall objective is to make a simulator of interacting populations. The unpacked objectives are: must use a class or two to create at least two populations. One population must begin the simulation with at least 40 instances. So in this example, the two populations are mice and cheese. And I believe both populations start with at least 40 instances. If not the cheese, then certainly the mice. The simulation must run without user intervention. It's fine to include choices for the user before beginning the simulation, but there must not be any influence on the outcome after the simulation begins. So as we see it run, there's no control over what happens. It begins with some random placements of cheese and mice, and then it goes, and there's no way to influence the outcome afterwards. The simulation must have at least two unpredictable, easily verifiable outcomes. These outcomes may be loosely interpreted, but are often distinguished as population A wins or lives, or population B wins or lives. Or the simulation persists indefinitely, we say that's in a living state, or the simulation is forced to stop and become in a dead state. In this example, there is no winning between the cheese and the mice. The cheese will continue to just generate periodically. The mice can either continue to live, but it will eventually die. So the two unpredictable, easily verified outcomes in this example are a long life for the mice or a short life for the mice. You must use graphics to represent instances. The graphics can come from anywhere as long as you are using them with permission or you create them yourself. I've had students create the mice and cheese graphics from the Mendocino High School. Instances of the populations, this is the last objective, instances of the populations must have an effect upon collision. Collision must look accurate from the user's perspective, which will probably require the interval collision technique because graphics are inherently rectangular. So we'll go back to this example of a simulation. Notice that the objectives do not require the printing of any information. That was done just as an example. We can see the printing of the lifetime in seconds of the mice and how many times the simulation is run. When we run our PyLife programs, it's only necessary to run the simulation once. If after the simulation is finished, the program ends, that's okay. If we needed to restart the program to restart the simulation, that's okay. What we see in this example is the simulations, once it dies out, which it's doing now, and then restarts, then we see it can keep on going indefinitely and run many simulations in a row. I did that so that we can see the difference in the lifetimes of the mice, to see that there are two easily verifiable outcomes. In this case, we're interpreting one outcome to be a long life, like 199 seconds, and that long life is not uncommon. Here we have 161 seconds. And then the other one is a very short lifetime by comparison of the mice of 13 seconds, or even a short life like 17 or 23. The collision is done by proximity. I can turn on a mode in which the graphics are replaced by solid colors, which makes it a solid color rectangles that are the same size as the graphics being used, to more easily see how the collision is happening between the brown mice and the yellow cheese. Interval testing is collision is being used, and we can see that once any of the brown sides of the rectangles meet up with the stationary cheese, collision is detected and the cheese gets eaten. It is unnecessary to show this in a completed program. This was done so that the interval testing can be more easily seen that it's been a part of this program and is the detection algorithm that's being used. It's the graphics that we want the user to see. It is also unnecessary to make a custom mouse cursor, but that's kind of fun. Have fun.